Thanks. Better? Better. So yeah, let's go to see some humanoid robots. You've already saw the demonstrations earlier, but now we will talk about what can they do and what could you do with those. So I'll start with HRP2, which is the first one we had. So this one is pretty high and 30 degrees of freedom. It has been created in 2002 and we got the one we have in 2006. So you can see that as it still works, it's a really reliable robot, but it's also kind of old for this kind of hardware. But also in terms of software, because the provider gives only Ubuntu 10.04, which is really aged. We managed to upgrade some of our software on it on Ubuntu 14.04, but still this is a bit also old. So Kawada provides some tools with the robots, which are called OpenHRP and OpenRTM. These are open source, but they are not really well maintained anymore. And we can also provide our systems developed in Gepetto, which are Pinocchio and the stack of tasks. So you saw today's demonstration with HRP2 working on some stepping stones and climbing stairs. So this is a kind of software which will use both at this point. So if you want to learn about these softwares, I will come back to this later, but if you want to learn how to use Pinocchio and the stack of tasks, basically we can do experiments on HRP2, even if everything else is pretty old. For this, you will need C++ and Python. So basically, we make everything in C++ to get the speed, and to ease the use of the C++ code, we bind everything in Python and then use the Python to call for C++ code and controllers and so on. Next, we have Pyren, which is a Talos robot from PAL Robotics. You also saw it in the demonstration earlier. So it's also a humanoid. It's even higher than HRP2. It starts to be really heavy. It has 2 more degrees of freedom, and it's really younger. So it's a brand new robot, meaning that the software is almost up to date, but we still have a few issues about its youth. Basically, we have the first robot. We have the first model of Talos, so it was a prototype, and we encounter a lot of small issues that we fixed in the way. So it works pretty well. About the software environment, we are currently in Ubuntu 16.04 and using LAAS-CNRS, but PAL Robotics promised us that in early 2020 we will have Ubuntu 18.04 and ROS Melodic, which are really up-to-date systems right now. From the software you can use, so I should have stated that before, but in Gepetto we are only concerned about motion generation in anthropomorphic systems. So we have humanoid robots to make them move, but maybe you want to use humanoid systems for something else than motion generation. You can use those for to check your vision algorithms or human interactions or any other kind of task. So I might not be an expert on how you could use vision algorithms on these robots, but that's still possible. We can talk about that. from the software and the robot, we also have Pinocchio and a stack of tasks, and we develop more tools with some partners from the Memo project, so which are TSID, Crocodile, and the multi-contact locomotion planner. I will come back to this later again. This is all the tools that have been written by us. But PAL Robotics also provides the ROS interface for everything. You can just ask the robot to move with a joystick. So you saw the experiments earlier. So this is just a standard ROS system. So if you know ROS, you can use the robot. We use the same tools as in HRP2 plus ROS on this. If you wanna try the tools we write, everything's most important ones are here. So Pinocchio is a C++ library to implement rigid body dynamics algorithms. So basically, this is the software library that will tells you if I apply a certain torque on my robot, how will it move? Given that this is a complex kinematic chain. And we also have the stack of tasks, which is a way to give high-level tasks to the robot in a hierarchic manner. So for example, the first task you will give to your humanoid robot is don't fall, and it will try to keep its equilibrium. But the second task could be put your left hand on the door handle. So it will try to use some degrees of freedom to put one of its end effectors to a certain point in space, for example. And you can provide tasks like this as long as you have some degrees of freedom left on your robot. To go further, so this is the way we consider how we should handle the problem of locomotion. So this is the Loco 3D framework. So basically, what we want is to go from point A to point B, given a robot and its environment. So first, we have a planner that try to see if the robot can move, can find a trajectory where it is not in collision with its environment, but the end effectors can can follow this environment. After that, after we have found a trajectory for the center of mass, we find some contact sequences. And after that, we make a whole body motion generation. So for all of these separate tasks, we have several softwares which are open source and used by other members of the Memo project. These are TSID, Crocodile. Well, so if you work on this kind of problems, we can just put your software in the chain and use the tools we already have for the other parts. It works well because we just used to switch some different planners or solver and can play with this kind of things. That's not all because we have other robots which are not humanoids. So for example, we have this guy. This is interesting for us because we want to write software that are that will work equally well on the different kind of robots. So my software, which make my left hand go to a certain point in space, should work equally well if I have two legs or not. So this is why we also have a Tiago. Basically with exactly the same software, well, as it's the same provider, it's also a robot from PAL Robotics. you can write exactly the same software and check that if the software works equally well on the humanoid and on this one, which is a mobile base. So it has only 12 degrees of freedom. It's also Ubuntu and ROS, same skill requirements as in TERRInet. And about the basic training package, I will just provide this link to ROS wiki, because we didn't develop anything specific for that robot yet. So you can use all standard ROS tools and they just work. But obviously the other things we talked about will also work on this robot. And last, we have this little guy here. So this is a quadruped, and once again, it should be able to find its way in an environment with the algorithm we develop. The only difference is that it has 4 legs instead of 2, but it should be able to locomote also. So these were really wrong. I didn't get the correct answers for the size and height. But yeah, it's a brand new robot, and it's completely open source. You can even you can try to use ours, but you can also build your own. It will cost like 5,000 euros. For the software environment, everything works really well with our stack, but also with PyBullet, which is a really thin wrapper around Bullet. So it will also work with Gazebo, but PyBullet is really lighter. And that's it for Geppetto's robots. So maybe now if you have some questions about those robots, or do you have plans to use those? Yeah, so should need some.
Go back to maybe just the list of software that you are presenting.
So I talked about what is Pinocchio, which is handling the kinetic and the dynamics of a chain of solids attached together via joints.
So it's all for what is related to modeling
Stack of tasks is a way to define goals in a hierarchic manner and actually solve the task. So basically you get one main task, it will consume some degrees of freedom of your robots, and at the end you will get the torques to apply or the position to apply on your actuators, depending on if you want to control your robots by position or by torque. TSID and Crocodile, these are the parts here in the whole body motion generation. So it's these are 2 different softwares that works for the fourth part. So the whole body motion generation is when you have the trajectory of your center of mass and the contact sequence you want. Both of these tools can generate all of the controls for your actuators. And multi-contact locomotion planner is at the second level contact planner here. So provided the trajectory for the center of mass, it will give you the sequence contact. So this is just a way to split the problem in several subparts, and we have several solvers for each part. Okay.
Maybe some words about crocodile, you say?
Crocodile is whole body motion generation.